In this video, we're going to be looking at atomic radius, what it is, what's the trend, and how valence electrons and energy levels affect the atomic radius size. So atomic radius is half the distance between two identical atoms and their nuclei that are bonded together. And the reason it is half that distance is because atoms don't really have a defined edge. The electron cloud is just an area where electrons hang out, but the electrons are always moving. So there's no definite stopping point because electrons aren't always in the same place. And so by bonding them together, if we can measure the distance between their center and divide by 2, we can assume that point would be where it ends. Basically, this is just a fancy way to say that we're using size or comparing the size of the atoms. And so the first thing that affects that would be your number of protons and electrons. And so when you have more protons and electrons, you have a stronger attraction. So beryllium has a stronger attraction between those two because it has more protons. It has 4 and 4 electrons. Lithium has a weaker attraction to the center because it has less protons and electrons, which means there's less attraction. The amount of attraction affects how close those electrons are pulled into the center. So the stronger attraction, the electrons are pulled in more. And so that is what makes it smaller. Because less protons and less electrons means there's less attraction, they are not pulled in as tight, which makes them larger. So the key point to this is that more protons means there's a stronger attraction between the nucleus and the electrons, which causes them to be pulled in more, making the atomic radius decrease. So, knowing that, we know that our right side of the periodic table has a high number of protons and our left side has a low number. So we can label it using an arrow to show the direction that atomic radius actually gets bigger. And so the right side is going to be where it's the strongest attraction. Left is going to be where it's the weakest, which means that it gets bigger as we go to the left. So looking at Al and Cl, they are both right there on the periodic table. Al has an atomic number of 13, Cl has an atomic number of 17. The one that's going to be larger is going to be Al, and there are a few reasons for this. One, it's more to the left, and so if my arrow goes left, pointing to the one that's bigger, it's going to be pointing to Al. 2, Al has less electrons, which makes it a weaker attraction, we know that a weaker attraction means the electrons are not pulled in as tight, so that it actually makes it larger. We can also label helium is actually our smallest. So when we're trying to figure out which one's bigger, which one's smaller, the closer it is to helium, the smaller it will be. The other reason or thing that affects the atomic radius is the row that it's in. So as we go down the periodic table, like this, we increase the energy levels or the number of rings. So row number equals the number of rings or energy levels. So row 1 would have 1, row 2 would have 2, row 3 would have 3, 4 would have 4, 5, 6 would have 6, and 7 would have 7. And so as you go down the periodic table, we're adding another ring on to the atom, which is partially why it gets bigger. Now, even though we're adding electrons and we have more protons, it does not get smaller because of what we know as shielding. So if this is our nucleus right here, this would be like the first ring, this would be the second ring. We know that opposites attract. So we know that there's attraction between this electron and the nucleus, but opposite charges repel. Nope, that is not right. Same charges repel. So every time we add a new energy level with electrons, the inner electrons are pushing the outer electrons from the new energy level away, causing it to get bigger. So, yes, as we go down the periodic table, the number of energy levels increases, which is partially why it gets larger. Your answer isn't complete, though, unless you explain shielding, where as we add energy levels, the electrons that are being added are being pushed away by the electrons that were already there on the inside, which causes it to get bigger. And the reason we call it shielding is because your inside, your inside electrons are shielding the nucleus. Okay. So on your periodic table, we would stick with this arrow going down to show that the bottom is much larger than the top. And so francium is actually your largest or biggest element. So the closer an element is to francium on the periodic table, the larger it will be. So we're going to try figuring out which is larger, fluorine or chlorine. So fluorine is right here, chlorine is right there. So fluorine is in row 2, chlorine is in row 3. which means fluorine has 2 energy levels, chlorine has 3 around the center. So just based off of that alone, we know that chlorine's going to be larger because it has more energy levels, which means more repulsion, pushing electrons out. You also could have figured it out because if we know it increases as we go down, our arrow is pointing to the one that's going to be bigger. And so it would be pointing to chlorine, which makes that one larger as well. And then the last one that we are going to do is magnesium or boron. So Mg or B. And this one's a little different because they are not in the same row or column, not in the same period or group. And so we kind of have to look at their relative location to francium and helium. So magnesium is closer to francium and boron is closer to helium. We know that francium is our largest element, and so magnesium is going to be the larger one. So it's closest to francium, but also it has less less electrons and protons than boron. No, that's not right. What am I doing? So it has more energy levels, which causes more repulsion. Boron has is more towards the right. It has more valence electrons being added, which will cause it to move in or be pulled in closer. So magnesium, it has more energy levels, so there's more repulsion, and it only has one valence electron on the outside. So it's got a lot of, like if this is our center, it's got a lot of things blocking the nucleus from pulling in that valence electron that's on the outside. It also has 2 valence electrons, not one. So to sum up, as we go to the left and down the periodic table, our atomic radius will get larger. Reason being, there are less electrons on as we go left. So there's not as much attraction pulling it in towards the center. And as we go down the periodic table, we have more energy levels. And those electrons on each energy level are causing repulsion between them, pushing them away.